Breaking the Wall of Metal Mining. Alexa Zytnick. Falling Walls Lab, San Francisco Bay Area.
Every single one of you has a treasure chest in your pocket. You use it every day to communicate with loved ones, to surf the web, maybe to read election news. I'm talking about your smartphone. And it's not just a treasure chest full of information, it's a treasure chest full of critical metals known as rare earth elements. Rare earth elements are essential for the technology that we use, not only as individuals, but even as countries. They're essential for hybrid car batteries, wind turbines, and telecommunication cables. The problem is, the way that we currently mine for these metals is incredibly toxic. We use harsh acids that are bad for the environment and bad for workers. Even worse, the world's largest exporter of these metals, China, is set to deplete their mines as demand will soon outstrip supply. Moving forward, how are we expected to produce the technology that we need in a safe and sustainable way? The solution? Biomining electronic waste with bacteria. Every few years, you probably upgrade your phone or your laptop, and this contributes to the worldwide production of 52 million metric tons of electronic waste every single year. This is a huge, incomprehensible number, but to give you an idea of scale, it's equal to the weight of about 130 Berlin Walls. This is a huge cache of rare earth elements that are just getting thrown away into a landfill, and almost none of them are being recycled. Luckily for me, the bacteria that I work with need these metals to survive, just the way that you and I need metals like iron or magnesium in our diets in order to stay healthy. The question is, can we leverage this bacteria's nutritional need for rare earth elements in order to mine them from electronic waste? In the lab, I've been studying just that, trying to understand how these bacteria sense and acquire rare earth elements. I've discovered a new molecule that they secrete into the environment, and when it's out there, it binds rare earth elements and brings them back into the cell for use. Using this insight, I've engineered these bacteria to produce more and more of this molecule, turning them into super consumers of rare earths, and they can now uptake 300% more metal than they could have naturally. And once they've taken up that metal from the electronic waste, we can reuse it in the production of new technologies. Better yet, we've partnered with economists, and we know that this practice can be scalable and can be competitive with conventional mining practices. And not only is this process scalable and competitive, but it's a green one that doesn't use harsh acids, so it's safe for our environment and safe for our workers. By generating a circular economy for the extraction of rare earth elements, I am breaking the wall of metal mining. Thank you.